Hello, today what we'll be doing is graphing a function and its derivative and a tangent line for that function to see how they're all related to each other. First, what you need to do is go to your input and type in a general function f of x equals ax to the third power plus bx to the second power plus cx plus d, and then you're going to create sliders for that function. So we've got all four of our sliders for a, b, c, and d, and notice as we change, each slider changes the function in a particular way. The next thing that we're going to do is we're going to create point A. We're going to construct it so that it is on that object. Let's put it right here. So now we have point A on my function f of x. Just to make sure that it's on my function, what I'm going to do is click on the move tool and see if I can move it left to right. And the only thing that does is keeps it on the function left to right. So it's on my function. Now what I need to do is construct a line tangent to that point. To do that, you need to go into your construction tools and go down to tangents. The first thing that you must click on is the point, and the second thing you must click on is the function. So now this line G is the line that's tangent to the function at point A. And if you click on the move tool yet again, you'll see that as I move point A, the slope of this line G changes. So it's always going to be tangent to the function f of x at only point A. The next thing that we're going to do is we're going to find out what the slope of that tangent line is. To do that, we have to go into our measuring tools, click on slope, and all we do is we just select the line. And what it does is it tells you what that slope is from point A. So now what I'm going to do is I'm going to just adjust my sliders and adjust my point A to where I want them. Notice that as my value of A gets closer and closer to 0, this function changes, and then as it goes into the negatives, you see that right part of the function actually goes down to the right. Point B, or I'm sorry, not point B, coefficient B, if we change that, all that does is it changes how much of a dip this has. And then point C changes the same sort of thing. So we're going to do this, and then point D actually moves it up or down. Not point D, constant D moves it up or down. So that's how I want mine to be. And I'm going to move point A. Notice that this slope gets really steep really fast right here. Now the next thing that I'm going to do is I'm going to create a point D so that its x value is the x value of point A, and its y value is the slope of the tangent line at point A. So in here, I'm going to just put in x of point A, comma, m, and then press enter. It calls it point B, but we want it to be called point D. So I'm going to right click on this and I'm going to rename it point D. And you'll see why it's going to be called point D in just a minute. Now the next thing that we want to do is we want to change the colors up a little bit so that it stands out. So right click on point D and we're going to go into settings. And we're going to change the color to this really bright color. Press enter and then go to the basic tab, and we want to show the trace of it. We want to see where it's been. So it's going to basically put a paint dot on your paper wherever it's been traveling to and from. Okay, so now what we're going to do is we're going to move point A along my original function f and see what happens to point D and how it relates to everything else. So close this out, and now we want to make sure that we're on our move tool, which we are. I'm going to take point A, and notice that point D is really close to a y value of 2. Notice that my slope of my tangent line is really close to a value of 2. Notice that point A's x value is at about 0.8, and you'll notice that point D is always going to be right above it at that same one. So as my slope decreases, point D moves down, and now notice that right here my points seem to coincide with each other. And then my slope is negative here. My slope is negative here. And then my slope is positive again. So every time my slope is a negative value, I'm below the x-axis. Every time my slope seems to be really close to 0, my point D is almost directly on the x-axis. So this point right here is where point D crosses the x-axis. And then also this point right here where the slope changes from negative to positive, that's where my point D goes across the x-axis. Notice that this particular trace looks an awful lot like the derivative function, if you're familiar with calculus. Of course, the derivative of a cubic would be a quadratic, so it makes sense that it's tracing a parabola shape. Now what we're going to do is we're actually going to plot the derivative function. To do that, you do f prime of x equals, and you actually type in derivative, and then square bracket f, because we're wanting to do the derivative of function f. And we're going to go ahead and change the object properties now. I want to recolor it. I'm going to color it the same color that we have point D, just like that. So now I've got function f prime, which is my derivative function. I've got function f, which is my original function. I've got line G, which is my tangent line. I've got my slope of the tangent line, which is m. And I've got my x value of point A, which is going to be telling me the x value of point D. So now let's move point A and see what happens. Notice that as I slowly move point A, it perfectly traces my derivative function f prime. So what does this tell us? Well, Basically what this is telling us is every time I move point A and I take the x value of point A and then the slope at point A and plot that, it's taking the derivative at every single point where I'm putting point A and then plotting that as a set of points. That set of points actually becomes the general derivative function. So the derivative of a function at a particular point is going to map to a single point which lies on this general derivative function. And notice that when the slope is 0, that gives us the zeros of my derivative function here and here. And then we could further do the second derivative and see what happens there, but I think we're going to save that for a new video. This is a really good activity to use with your students to get them to realize what happens with the derivative and why particular points on the original function are important and how they relate to particular points on the derivative function. And then you can use that to actually teach them what the derivatives look like algebraically now that they've seen it visually. Thank you for listening.